we talked about our conditional statements, and then we talked about the converse of the statements. Remember, that was just when we took the hypothesis and the conclusion and we switched them. So all of the theorems that we learned yesterday about if two lines are parallel, then alternate interior angles are congruent. If two lines are parallel, alternate exterior angles are congruent. What we're doing today is we're technically proving the lines are parallel by using the converse of those. So if we take a minute and we look at our first one, and it looks like some of my words are cut off. It just says two lines right at the beginning of that first theorem. Is it just my first couple of letters that are cut off? If two lines. Okay, so if two lines are cut by a transversal so that corresponding angles is what we need to fill in first, corresponding, are congruent, then the lines are parallel. So basically, I could spell today, might help. It's the converse of what we talked about yesterday. We said yesterday, if two lines are parallel, then corresponding angles are congruent. Today we're doing the converse of that. It says, if corresponding angles are congruent, then the lines are parallel. Basically just switching the order of those. The method in which we solve all these problems is not going to be any different than what we did yesterday. Okay? The only difference is the way that it's stated in the directions. The next one, if two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then the lines are parallel. Again, just the converse of what we said yesterday. Yesterday we said if the lines are parallel, then alternate exterior angles are congruent. That is the same for alternate interior angles as well. The next one says, if two lines in a plane are cut by a transversal so that same side, interior or exterior actually, but we'll just put interior, are congruent, not congruent, supplementary, sorry, that was my bad. Then the lines are parallel. Again, exactly the same thing we did yesterday, except for it is the converse of it. So instead of saying if two lines are parallel, then same side interior angles are supplementary. This time we're saying if same side interior angles are supplementary, then the lines are parallel. It's the same stuff. It's just stated backwards using the converse. Okay, the next one says if two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. And then also the one about the perpendicular lines, the converse of that is true. So this time it says if two lines in a plane are perpendicular to the same line, then the lines are parallel. So nothing about the rules that we talked about yesterday have changed. It's just the way it's stated in the directions. Your directions, instead of saying these lines are parallel, find the measures of the angles, this time it's going to say find the measures of the angles that make the lines parallel. But the rules are all still the same. Is everybody okay with that? The only difference is the directions as far as what it's telling you to do. It's telling you to find the angle measures so that the lines are parallel, which is exactly what we did yesterday. All right, so let's take a look at our first example. It says, use the given information to determine which lines, if any, are parallel, and then state why. What kind of angles are they? You don't have to tell me the name of the postulate. Just tell me what angle pair they are. So let's start with angle 2 and angle 8. I'm going to highlight them so I can see them better. Angle 2 and angle 8. Okay, looking at those. If I were looking at those, first of all, what's the transversal for those two? What's the one line that touches both of those? That's an L, but yeah. Everybody see that one? Okay, so that's my transversal, which means what two lines would have to be parallel? What are the other two lines that angles 2 and angle 8, or angle 2 and angle 8 touch? A and B. And let me ask you this, what kind of angles are 2 and 8? Alternate interior, alternate exterior, same side interior, same side exterior, corresponding. Alternate interior. So what we're going to say is we're going to say that line A is parallel to B, and that's how you write that. You write the lowercase a with the two little parallel bars, okay, and then B. And then I just want you to tell me what kind of angles they are, which we just said would be, alternate interior. Does that make a little bit of sense? You'll have to do this on your test, just FYI. All right, take a look at the next one. Angles 3 and 11. Okay, angle 3 and 11. First of all, what would be the transversal? What's the one line that they both touch? A, which means which two lines would have to be parallel? L and M, yep. So L is parallel to M. And then what kind of angles? Let me erase my line highlighting. What kind of angles are they? Alternate interior, alternate exterior, same side interior, same side exterior, or corresponding? Corresponding, yes.
Good morning. Pardon the interruption. At this time, will teachers please release all freshmen attending the field trip to go to the gym? All freshmen attending the field trip should report to the gym now.
We don't have any freshmen, right? Okay. All right, try 12 and 14. Tell me what you think the two lines are that would have to be parallel for 12 and 14, and then tell me what kind of angles they are. I want you to try that one, okay? Look at your angles 12 and 14. It's easiest to decide what the transversal is because then you can easily tell what lines would have to be parallel. And then tell me what kind of angles are they? Are they alternate interior, alternate exterior, same side interior, same side exterior, or corresponding? Looking at angle 12 and 14, what two lines would have to be parallel? A and B. And then what kind of angles are they? Exactly, alternate exterior. Is everybody kind of okay with that? Okay. All right, the next section, we're doing exactly the same thing, but these are going to be just a little bit trickier. Okay, so with the next question, we're looking at angles 1 and angle 15 being congruent. I'm going to make this a little bit bigger so I can actually see it because it's too small for me to see. All right, look at angle 1. Whoops. Try that one more time. Look at angle 1 and look at angle 15. Here's my first question. Do they share the same line? They don't. Do you notice how they're in different corners of this diagram? Our angle 1 is with a line L and N. Angle 15 is with M and K. If they are not on the same transversal, if they do not share a line, then they cannot be congruent based off of anything we talked about yesterday. Okay, so what I mean by that is if I were using alternate interior, alternate exterior, same side interior, same side exterior, you would have to use either those angles as any combination of those 8 angles or any combination of those 8 angles. Or we could go the other direction. We could go those 8 angles and those 8. But we can't separate it into 2 separate lines there, okay? So in this case, let's quit getting tongue-tied. 1 and 15 cannot prove that lines are parallel because they are not alternate interior, they are not alternate exterior, they're not same side interior, they're not same side exterior, they're not corresponding. So on this one, we would just write none. Okay. Now the next one says that the measure of angle 3 plus the measure of angle 10 is 180. That means 3 plus 10 is supplementary. So let's take a look at 3 and 10. Do those share a line? Yes, they do. So that means they do have a relationship. What kind of angles are they? Same side interior. So which two lines would have to be parallel for that? N and K. Okay, so N is parallel to K. And then you just told me that those are same side interior angles. That's my K. It's like a cursive K. It looks a little funky. All right, then look at 3 and 5. I want you to answer that question. Angles 3 and angle 5. What lines, if any, would need to be parallel, and what type of angles would they be? Are they sitting on the same line? Yeah. So which two lines would have to be parallel? L and M. And what kind of angles are they? Alternate interior. Yes, they're in between the lines, but on opposite sides. So what did we say? L and M? And they are alternate interior. If you look back at the pictures, my transversal is N. They are on opposite, whoops, try that one more time, go a straight line. They are on opposite sides of that transversal. They are both in between my lines. That makes them alternate interior angles. Everybody okay with that? Sort of. Okay, so for the next one, it says find the value of y so that E is parallel to F. Take a look at your picture. What marking do you see? The right angle. And we learned that if one line is perpendicular to another, what did we say? It's also perpendicular. What did we learn yesterday? If a transversal is perpendicular to one line, then it's going to be perpendicular to the other line as long as those lines are parallel. So if I wanted to set up an equation to solve for y, even though it looks like half my y got cut off, what would we do? If this is perpendicular, what do we learn about this other line? It's also perpendicular, which means it's equal to 90. So if that angle is equal to 90, what would 4y plus 10 be equal to? 90. So that's what you need to do. Set up your equation. 4y plus 10 is equal to 90. We know that because we want the lines to be parallel, which means they have to be perpendicular to both, or D has to be perpendicular to both E and F. In that case, that makes that angle 4y plus 10 equal to 90. So then we can solve that one for y. And what would the value of y be? 20. So I would subtract 10 over. That would give me 4y equals 80. And therefore y is equal to 20. Everybody okay with that? Okay. Okay, it seems to be I'm missing a question. Find the value of x so that m is parallel to n. Okay. All my stuff got cut off apparently when I said that. So what we want is we want to prove that L is parallel to n. So we want to solve for x. Let me ask you this. The 6x minus 3 and the 2x plus 1, what type of angles are they? Alternate interior, alternate exterior, same side interior, same side exterior, corresponding. Corresponding, right? And what did we learn about corresponding angles yesterday? They are congruent. So if you wanted to solve for x, what would you do with those two?
2x plus 1 would be 6x.
I just started to write the 6. I'm going to do that one first. But either way, it doesn't matter. As long as you set them equal to each other. And then solve for x. So take a minute, set that equation up. Solve it for x. Let's see what we get. What'd you guys get? 1. Right, 1? Okay, yeah. So let me see. I'm going to subtract my 2x over. That's going to give me 4x minus 3 equals 1. Add my 3 over. Running out of space. That's going to be 4x equals 4. Divide by 4. Yes, so x equals 1. Is everybody okay with that? Okay. All right, I want you to try the next one. It is a multiple choice, so you do get options. It's wanting you to find angle LMN. So let me highlight that so you can see which one it is. And you have your choice of 2 other angles to use. You just have to decide, are you going to use the 9x minus 12, or are you going to use the 2x plus 152.4? Either way, you have to decide what kind of relationship they have, and does it mean that they are congruent or supplementary? Depending on which one of those you use, it will change the way you set up your equation. Then solve for x. It does not matter to me which one you want to use. It's just a matter of which one you see and what relationship they have and what would be easier for you to solve. I probably would choose the 9x minus 12 just because I don't want to deal with a decimal. How many of you would agree with me on that? Yeah. Okay, so let's look at that one. 9x minus 12, look at that angle. What kind of relationship does it have? Alternate interior, alternate exterior, same side interior, same side exterior, corresponding. Okay, is it in between the 2 lines? Are those angles in between the 2 lines or outside the 2 lines? Your 2 lines are these 2. So are those angles on top and bottom or in between? Top and bottom. So that means they're on the outside. Are they on the same side of the transversal or opposite sides of the transversal? Opposite. That makes them alternate exterior, which means they are congruent or supplementary? Congruent. So let's set up your equation then. 9x minus 12 equals 4x plus 6. I want you to solve that for x. That is not what they are asking us for, though. So once you get x, do not go ahead and circle your answer. We're going to have to plug that back in to find the angle. once you get that, you're gonna have to use that answer to find out the measure of angle L. And what is it, K? L and N. Sorry. I lost my pen. What'd you guys get for X? 3.6? Do you notice how 3.6 is an answer? So the reason we're talking about this is because they could give you a question like this on the EOC, right? And you set it up correctly and you solve it and you say, oh, there's my answer. They didn't ask us to solve for X. They asked us to find the measure of an angle. So you're going to need to be very careful with those when you are taking the EOC or any kind of standardized test, because they do throw those tricks out there trying to confuse you, because you'll say, oh, I got that answer, so that must be the right answer. Hold on, I'm trying to solve it real quick. So we get 5x equals 18. 5 does not go into 18 evenly, but we divide it out and we get 3.6. But again, they did not want x. They wanted the measure of angle LMN. How did they represent LMN? In your picture, what do they say LMN is? 4x plus 6, right? So what we're going to need to do is then plug that in. We're going to go 4 times 3.6 plus 6. And what do we get? 20.4. That is also an answer, isn't it? So that is going to be the correct answer. So just be careful, especially if you get some multiple choice questions like that. Be careful and make sure that you are actually answering the correct question, because I guarantee you they'll ask you to plug that x in, but they'll give you the value of x as an answer, because you say, oh, well, there's the answer because that's what I got, but you just didn't finish the question, okay? So be careful with those. Alrighty, can you guys read those numbers in that picture? I know it's kind of hard when it's black and white in that first picture. Yeah, 124 and 50. So what kind of angle pair are those? The 124 and the 50. Are they alternate interior, alternate exterior, same side interior, same side exterior, corresponding?
Same side exterior.
Same side exterior. And what are same side exterior angles supposed to be? Supplementary. So what it's asking is, do you have enough information to say those lines are parallel? Which means, do the angle 124 and 50 add up to be 180? What do I get if I add 124 and 50? 174. Is that 80? I mean 180? So do we have enough to say that these lines are parallel? No.
No.
All right, and then I want you to answer that last question. Can you see the numbers there and that's inside that picture? 120 and 54 again. Is it possible to prove that those support poles are parallel? So decide what kind of angles you have, the 120 and the 54. Are they alternate interior, alternate exterior, same side interior, same side exterior, or corresponding? What are they in that picture? It might be easier to look at my picture because it actually has them highlighted in red, or at least the sides of them anyway. Let me make it a little bit bigger. Your angles are right here, the 120 and the 54. Same side interior, same side exterior, alternate interior, alternate exterior, corresponding. Same side interior, and what do we say about same side angles? They're supposed to be supplementary. Are those two supplementary? No. So now be careful, because there's two options in your multiple choice that say no. You have to choose the right one. No, because what reason? Read what we say. The first one says no because the same side interior angles are not supplementary, so the support poles cannot be parallel. Did we say that they are same side? We did, so that might be the right answer. Let's check the next one. It says no because alternate interior angles are not supplementary. Are those alternate interior angles? No, what did you just tell me they were? Same side, so what's better, A or B? A.